Okay, so continuing our work on things that are directly proportional. So let's just look at this little snip that's out of the textbook. So if two variables are directly proportional, what that means is the rate of change of one variable with respect to the other is constant. So in other words, they're going up at the same rates. The graph is a straight line. It's really important that you understand that it passes through the origin, just like the example we did. The rule is in the form y equals mx, and we know that from when our work with only one intercept earlier. If there is no constant, that means it's going to go through the origin, because we know that if y is 0, then x is 0 and vice versa. The gradient of the graph equals the rate of change of y with respect to x. So it equals how much it's going up by. So just remember that this does not mean that each variable goes up in exactly the same amounts. It means they go up by the same distance on each side. So let's have a look at another example here. So a 300 litre fish tank takes 3 hours to fill from a hose. What is the rate at which the water poured into the tank? So we can pull that information straight out of the question. So 300 litres in 3 hours means that in 1 hour it's going to be 300 divided by 3, which is 100 litres per hour. So rate is usually expressed as a certain amount over a certain time period, 100 litres per hour, a certain amount of kilometres per hour, something like that. Hour is pretty common, but it depends on the question exactly what you use. So next one, draw a graph of volume V litres versus time T hours using 0 is less than or equal to T, which is less than or equal to 3. So what that means is we only want values for T, which is going to be on our x-axis, between 0 and 3. We don't want any others, is all that means there. So T is between 0 and 3 is all that means. So there's a couple of ways you could do that. So one, draw a table like we did. Or, because we know we can fairly easily find out the starting coordinate and the finishing coordinate, we can just use those to do it. So our other option is to plot 0, 0. We know it's going to go through the origin because we know that because it's directly proportional, and 0 litres at 0 time makes total sense. And we know that in 3 hours' time, we're going to have 300 litres. So that can be our ending coordinate or our second coordinate of our line. It ends the variables that we're interested in, because remember it says we only want between 0 and 3 for our t. So ends of the variables, and we can draw a straight line. So I'm just going to use that second option, and I'll show you what that means. So little graph, t, litres. We really should label our axes explaining what they are. So the y-axis is showing us tank volume in litres. Our x-axis is showing us time in hours. 0 is where it's starting. So I'm only going to go up as far as 4 because we only want between 0 and 3 anyway. And we know that there's 100 litres per hour. So 100 seems like a good scale to use on our vertical axis. So our first point, at 0 hours, there's 0 litres in the tank. So that's where we plot our first coordinate. We also know that at 3 hours, there's 300 litres in the tank. So that's how we can plot our second coordinate. And of course, then we can just draw a line between them. Now, you should have an arrow because it is still going, but that's really all we're after here. And of course, we don't have a rule to label it at this point, so I'm not going to put that on the axis, but that's part of our next thing. So find the gradient of the graph and the rule for V. So gradient first. If we use rise over run, we can use those 2 points and that amount of money, the values we have to find this. So we know if our first point is 0 and our second point's at 300 for our rise, 1, 2, 3, then our rise there is going to be 300. We also know that if we start at 0 time and we go out to this point, that's 3 hours. So 300 over 3, which is 100 litres. Note that our gradient is exactly the same as the rate we found in the first place. So, and that will be the case most of the time. Now we've got this, pretty easy to write the rule because we know, and I'm just going to whiz back up here, we know the rule is going to be in this form because we know that these two are directly proportional because they're going up at a constant rate per hour. So our rule here is going to be volume equals 100 litres per hour times time, or the number of hours. So we can simplify that to V equals 100T. We don't need the litres here, we just need the number. And we've got our rule. Now, use our rule to find the volume after 1.5 and the time to fill 200 litres. So these are the similar types of things that we did last question. So we need to let T equal 1.5 here and use that with our rule. V equals 100T, which equals 100 times 1.5, which equals 150 litres, which equals the volume after 3 hours. Sorry, after 1.5 hours. Same as last time, but this time we've got an amount for volume. So this time our volume is 200. So we're going to substitute that in, write the rule first, substitute in 100 times T. T equals 200 divided by 100, so T equals 2. So should write a sentence. So therefore it takes 2 hours to fill 200 litres. So that is what directly proportional means. It means it goes up at the same amount. Your turn now. Have a go at these questions, exercise in 4E, and watch indirect or inverse proportion screencast for the next lesson and take some notes on that. Okay, see you in class.